In this part, we'll examine some of the most significant properties of lubricants. One of the most critical properties of liquid lubricants is viscosity. The thicker lubricant has a greater resistance to flow, so it has a higher viscosity, while the thinner lubricant has less resistance to flow and therefore a relatively low viscosity. The thinner the lubricant, the lower the viscosity. Viscosity is affected by temperature. Higher temperatures cause lower viscosity because lubricants thin as temperature increases. On the other hand, lubricants thicken as temperature decreases. Both cases are significant because a lubricant won't lubricate properly if it's either too thick or too thin. If a lubricant is used where large changes in temperature occur, the lubricant's viscosity index is important. The viscosity index is a measure of the lubricant's viscosity change in relation to temperature change. If, when temperature changes a large amount, the lubricant's viscosity changes a small amount, the lubricant has a high viscosity index, or VI. If, when temperature changes a relatively small amount, the lubricant's viscosity changes a large amount, the lubricant has a low VI. Consequently, the temperature at which the viscosity measurement was obtained must be stated. This information is important because the same lubricant will have different viscosities at different temperatures. In addition to viscosity, several other properties that affect lubricant performance are used by manufacturers as they develop lubricants for various applications. One of these properties is pour point. It's the lowest temperature at which a lubricant will pour or flow. Below the pour point, the lubricant will be too viscous or thick to flow by gravity. A low pour point indicates that the lubricant flows at low temperatures. A high pour point indicates that the lubricant needs higher temperatures to flow. The pour point is especially critical in machinery that must run in cold weather and in equipment that's used in refrigeration systems. Two other temperature-related properties of lubricants are flash point and fire point. The flash point of a lubricant is the lowest temperature at which the lubricant's vapor will ignite when it's exposed to a source of ignition. The fire point is the lowest temperature at which the lubricant will burn steadily when it's exposed to a source of ignition. This occurs because enough vapor is created to cause continuous burning. If either the flash point or the fire point is exceeded, a fire hazard exists. Resistance to oxidation is another significant property of lubricants. It refers to a lubricant's resistance to reacting chemically with oxygen when exposed to heat and air. You see, many industrial lubricants are made from hydrocarbons. When the hydrocarbons are exposed to heat and air, the chemical reaction called oxidation occurs. Oxidation causes chemical changes that destroy a lubricant's effectiveness and lead to the creation of deposits such as sludge and varnish. Oxidation also produces acids that cause rust and corrosion. The oxidation process is normally slow, and over time, most lubricants do tend to oxidize. Oxidation can speed up, however, if the lubricant splashes around excessively or if it's exposed to high temperatures. A lubricant's resistance to forming an emulsion is also important. Basically, an emulsion is a mixture or suspension of components that are difficult to separate once they've been combined. The process that causes the formation of an emulsion is called emulsification. A lubricant that resists forming an emulsion is usually desirable because an emulsion of lubricant and water has poor lubricating qualities.